So far, if you remember the initial crowd journey that I spoke about, we started from IaaS platform, moved on to hybrid, then we spoke about containers. Now it's time to talk about serverless and function as a service. Quickly, how many of you have either looked at AWS Lambda or used AWS Lambda? One, okay. So let me talk about what that is before we move on to what Platform9 is doing in that area. So if Pawan spoke about how we are moving into a world of services which are literally becoming smaller and smaller. But why do you want to stop there? A lot of the work that we do today is based upon API calls. Why not just take it down to functions which do one job and do that job correctly and efficiently? And that's what a function as a service is. You don't have to write processes. You can just write functions to your job. Those functions are short-lived. They can compute, and they can disappear. They can be triggered on mostly HTTP. So if you're making a request, do something, disappear. Or database triggers. Or if you're putting something on a message queue, you take it out, you process, you go away. Or if you're putting an object on object storage, you want to compute a different file size for it. You want to compress the image. You do that, and then again you go away. That's what a function as a service is. And the serverless frameworks makes it easy. They handle a lot of details around how and when to start them, how to do it quickly, and how to move it around once other functions comes in. Well, again, why are we doing this? Well, I think smaller is better. You focus on the smallest thing that you write. Don't worry about scaling. Don't worry about containers or virtual machine. Forget deployment. You're just writing code. You're just focusing on code. You're just focused on your Python code or Ruby code or Go or Java. And we're living in an API world where everything needs to have an API. Everything, your build system, your virtual machines, everything needs to have an API. And the serverless will automatically scale you. You don't have to worry about, oh, I need to have a replication set, or I need to have 5 virtual machines running, and I need to have a load balancer. The system will take care of that. And it's going to be economical, because if you're running a process all day long, when it's only called once in 4 hours, that's unnecessary use of the memory and the CPU. Well, that's where Fission comes in. So at Platform9, this started as a hackathon project, where we said, okay, Kubernetes provides a lot of these constructs, which makes it easy for people to write functions and consume it. Why not build something on top of that, which is AWS Lambda equivalent? Not exactly the same. It's different. It's open source. It's part of the community. People are developing it, and we are sponsoring it. So we have lots of open source developers around that. This is a project. This is not as part of the product yet, but it will make it to our product soon. Not yet. It's in early alpha stage. We are sponsoring it, but we have about 2,000 or so GitHub stars, so please do check it out. What I wanted to do was actually talk about the use cases. The technology is technology, that's great, but what am I going to be using it for? What do we use it for? So at Platform9, our DevOps team have many interesting use cases. They have many systems. So we have a system where alerts pop up when there are issues with our customer's environment. As I mentioned earlier, we are managing 300 plus regions. It's possible that in some regions, for some customer, servers got disconnected, perhaps they just died. There's an alert that pops up, which is great, but we have a giant dashboard. If it happens in the middle of the night, we may need to, depending upon some business rules, we may need to wake up a operations person or a support engineer. How do we do that? So we wrote a small function which says, okay, this was the alert, and it has some logic which says, the server went down, or 3 servers went down. This is something dramatic that's happening. Let me call PagerDuty or VictorOps or one of the paging services and wake up the person who's on the duty. And it gets more complicated. We use Zendesk as our supporting system. The ticket comes in, we look at the ticket and say, okay, this seems important. We need to now go and add an entry into our PagerDuty, or also put it on Slack because we use Slack heavily. So those are some of the use cases that we use internally for. Then you can also write small REST APIs. You don't have to start processes to make it work. You can just have one cluster where Fission is running. You can write the functions that you need. You can grow them as you want, and it will handle it for you. The other interesting use case, because we are built on top of Kubernetes, is extending Kubernetes itself. Kubernetes has events. So it will tell you when something comes up or something dies. You may want to do something interesting with it. One of the use cases that we worked on was, okay, Kubernetes, when it comes up, it will give you an IP address for the service that you just stood up. For example, the build service that Pawan spoke about. But hey, it's an IP address, it doesn't have a DNS name. Kubernetes doesn't support putting an external DNS name. What do we do? Okay, simple, write a Fission function, which will take that IP address and put an entry into your DNS server, and you're done. So those are some of the use cases. I'm not sure how many of you run into these really small, simple, gluing of many services kind of use cases. I'm pretty sure there are so many use cases that you are aware of. I would like to hear from you if you have seen any of those where you will find this interesting. Anyone?
We use Lambda functions for a variety of things like event management, right? So you just mentioned one of them, but a lot of times it's not a single function, it's a multiple functions. So it's not, if you have multiple functions together, you have to deal with either chaining them, which could, if you have an error anywhere in the chain, you have to handle the events and move on through the chain.
Yes.
Or you use step functions from Amazon.
Yes.
So, I mean, there's several different use cases there, but my question is, where is this running?
So this will run on any Kubernetes cluster that you have. So we are building it on top of Kubernetes. We want to use Kubernetes as the base. We want to use Kubernetes as the platform for running these functions. So it is not AWS specific. It can run on your data center if you have a Kubernetes cluster running on it. It can run in AWS, GKE, ACS, any of them.
So are we going to spin up the container and then run the function and then kill the container, or the container's running all the time?
That's where the magic happens. So I will show that to you. In short, you don't have to think about containers.
Fission does it for you, like Lambda. You don't think of the container under Lambda, it just apparently
it will automatically come up,
yeah.
It will die down automatically. And if there are many requests, it will keep it around. So there is a cache of it running all the time.
Right. So under the hood, though, you're going to spin up a container, run the function, and then kill the container. I only have to think about the function and calling the function.
Correct.
Okay.
Yep.
So I mean, one of the best things about serverless is that it's event-driven. And obviously, in a public cloud environment like Azure and Amazon, they've tied in all those events. So you upload something to an S3 bucket or something comes in via Kinesis, you can generate all these kind of events. On-prem infrastructure doesn't have an event bus generally that generates those kind of events. If you upload a file somewhere, you don't have the concept of doing that. How do you see that as a blockage for people adopting serverless?
So what we are doing, and this ties into some of the work that Pawan showed us. If you look at it, we showed how you can run these applications like databases or even queues on top of Kubernetes. What we see happening is you will be running these services on containers. And what we are seeing from the community is they are writing hooks for some of these events like S3 so that you can run Fission functions on that. Or if you put message on a queue like Nats is a pretty popular open source queue implementation. If you put something on the queue, it sends an event and you can run on it. Minio is an example of a company which has S3 equivalent functionality. If you put something on that, you can run a Fission function on it.
So that's two different. So is that two different things that you're able then to hook into other event buses? So for example, you can, I don't want to use the word monitor because that's not quite what it is, but you can watch the bus for S3 and something's posted on S3 and you can run then a Fission function.
Yes.
But then does Fission have its own event bus that other people can then write things onto?
Yes.
From other kinds of either containers or anything else?
So think about the triggers that Fission has as essentially the queue or the event bus.
Yeah.
So when you say, hey Fission, run this function when somebody calls this particular URL, it's actually going into an internal bus. So for you, that's an API. Obviously, there are
you
other
have separate access to that bus, so you can add events onto that bus, because obviously the message bus that Amazon or Azure is running is abstracted. You don't have any visibility of that bus, but because you need to connect to other third-party systems, you potentially want to be able to put something on that bus so your Fission function can fire.
Correct. So there are, as I said, there are two ways of doing it. A, you can have these extensions that Fission is already doing. That's one. The B is there's an open API by which you can push it onto the bus, and that's what I'm going to show you.
Okay.
And even though you think of that as an HTTP function, ultimately it's going on to a queue, which then goes to a function.
Yeah.